My name is Sarah Wilkinson, and this is the second part of a video series showing how to convert VO2 values. In this video, I'm going to show you how to easily convert a relative VO2 value to an absolute VO2 value. Please make sure you've watched the first video, which shows you the basic mathematical principle I'm utilizing to do these conversion factors, as well as a little bit of a backgrounder on what VO2 is. So in this video, I'm going to again show you how to convert a relative VO2 value, which is measured in milliliters per kilogram body weight per minute, to an absolute value of liters per minute. And I'm going to set it up, putting my relative value on the left-hand side, and on the very right-hand side, I've put in what I'm trying to convert to, so the absolute value of liters per minute. So let's use a theoretical example and say we have someone with a VO2 max of 45 milliliters of oxygen per kilogram body weight per minute. And this is essentially 45 mils per 1 kilogram minute. Normally we don't put the ones in, but just to show you what should be on the denominator there. I need to do two conversion factors. I need to convert milliliters to liters. Minutes will remain, but I need to remove kilograms. And for some people, whether to divide or multiply by 1,000 and divide and multiply by the actual body mass becomes a little confusing. So setting up in this manner helps you decide whether you need to divide or multiply. Again, the principle I'm using is that if 1 unit is on the numerator, so for this example, milliliters, I can multiply by a conversion factor and put the milliliters on the denominator in the conversion factor, and those two will cancel out. So we know how many milliliters are in 1 liter, and that's what we're trying to convert to here. There's 1,000 milliliters in 1 liter. So if I stopped at this point, by canceling out the 2 milliliters, I would take 45 and divide it by 1,000. However, if I stopped at this point, I would end up with liters per kilogram per minute. Remember, an absolute value is measured in liters per minute. So therefore, I must also, so-called, get rid of the kilograms. So I need to either divide or multiply by. And some people, this may be very clear to you. For others, not so much. So we're going to use the same principle again. I need to remove kilograms in my next conversion factors. And it's on the denominator on the left-hand side, you can see here. So in order to cancel it out, I need to put it on the numerator. Remember, top is going to cancel out bottom. Let's say for this example, the person I'm talking about is 78 kilograms. And again, that's over 1. The kilograms will cancel each other out. Top cancels out bottom. So to finish this off, all I need to do is multiply all the top numbers together and divide by all the bottom numbers. Because anything divided by 1 or multiplied by 1 is 1, I'm just going to worry about the numbers that are not 1. So I'm going to take 45 and multiply it by 78 and divide by 1,000. This gives me the answer of 3.51 liters per 1 minute. So in this example, I've converted a relative VO2 max value of 45 mils per kilogram per minute and converted it to an absolute value of 3.51 liters per minute. Let's do an example now. I want you to convert Stanley's relative VO2 of 30 mils per kilogram per minute to an absolute VO2 value in liters per minute. His body mass is 80 kilos. Please pause this video now, try this out on your own. Once you've come up with the answer, or if you get stuck, press play again. So again, we're converting a relative value in mils per kilogram per minute to an absolute value of liters per minute. Stanley's relative value is 30 milliliters per 1 kilogram minute. We want to be able to convert milliliters to liters, and again we set it up so that the numerator cancels out the denominator. We know there's 1,000 milliliters per 1 liter, and again, milliliters cancel out. We need to multiply by kilograms because in the relative value it's on the denominator, so we need to put the kilograms on the numerator. And we know that Stanley is 80 kilos. Again, kilograms cancel each other out. So in this example, I'm going to take 30 times 80 and divide by 1,000 to get my absolute value of 2.4 liters per minute.